So first of all, I have to draw your attention. This talk will be conducted in English. If you want to get a translation device, all the translation devices are outside, right next to the gate. حياكم الله في اليوم الثاني من قمة المعرفة. طبعا قمة المعرفة لهذا العام تندرج تحت عنوان الشباب ومستقبل اقتصاد المعرفة. بنواصل معكم جلساتنا الثرية واللي هي عبارة عن أحاديث أو خلينا نقول توكس من ناس مؤثرين في هذا المجال. عنوان جلستنا الأولى لهذا اليوم تحمل عنوان الذكاء الاصطناعي والتعلم الآلي، وضيفنا الأول في هذا اليوم بيكون هو مستر آدم جرينفيلد مؤسس شركة Urbanist بيتكلم عن الذكاء الاصطناعي وأشياء أيضا غيرها مهمة لنا كلنا. حياكم الله.
Thanks a lot, man. Good morning. Hey, how's it going? It's a real pleasure to be here. The talk this morning is called Artificial Intelligence Toward the Post-Human Production of Knowledge. And I think in the next couple of minutes, all of the words in that title that might not be clear yet will become clear. The very first thing I was asked to explain is what artificial intelligence is. And particularly, this morning, we're not going to be talking about robots. I was explained that when we discuss artificial intelligence here, very often people think that what we're talking about is robots. No, we're not going to be talking about that at all. We're going to be talking about what guides and controls the robots and so many other things in our lives now. We're going to be talking about algorithms that learn. What do these algorithms do for us? They are deployed in every facet of contemporary life, in things like pattern recognition and anomaly detection and machine vision. When taken together, these things give us natural language speech recognition. They give us autonomous vehicle guidance and control, so the cars that we're going to be seeing orbiting our streets and our roads in the next several years. They give us things like credit scoring, the idea of, are we personally trustworthy? Are we personally deserving of the credit that we're offered? Things like romantic partner selection, traffic and crime prediction, climate modeling and weather prediction, risk assessment, and even for autonomous weapon systems, automated threat identification and target acquisition. So a great many channels and dimensions of contemporary life, increasingly governed by algorithms that may not have been devised by any human person. And this is the important point. What an algorithm does in being exposed to a process of machine learning is to abstract pattern from the world. So whether or not you are a truck driver or a surgeon or even a creative artist, there are patterns in everything that we do. A machine learning algorithm is equipped with the ability to determine and extract the patterns from what it is that we do and turn them into portable instruction sets that can be taken away from us and downloaded into the control system of an autonomous vehicle or other robotic system that knows how to operate and make use of those algorithms. For example, this is an MH24 industrial palletizing robot over here in the blue. On the other side is a gentleman who spent 24 years of his life mastering the Japanese art of Aedo, the Japanese art of drawing the sword. Now, interestingly enough, he does not understand this as a combat art. Otherwise, that would be called Aejutsu. He thinks of what he does as Aedo, a spiritual pursuit. In drawing the sword, in practicing the art of Aedo, he's trying to get close to the ineffable nature of the mystery of the universe. He understands this as a deeply spiritual practice. What does it mean that he has been asked to wear a motion capture suit and spend days of his life working with the robot and the motion capture suit so that everything he knows, everything he's learned in the 25 years of practicing his art can be turned into an instruction set which is then downloaded into that robot? What does it mean for that robot to then perform the same moves as he does, but without the same spiritual aspect to it? When he draws the sword, he's trying to express the nature of the universe. When the robot draws the sword, even though it draws it in precisely the same way, it cannot be expressing the same thing because the robot, as we understand, doesn't have a soul. The robot, as we understand, is not human. The robot is merely enacting an instruction set. And yet, It will do what the sword master does better than he does, tirelessly, relentlessly. It will draw the sword 10,000 times over and over and over again, perfectly, flawlessly, until the edge of the blade is worn away through ablation with the air. When we have a context like this, in which a post-human system is enacting a deeply human set of prerogatives and ambitions, we have entered the eclipse of human discretion. We have entered a time in which post-human systems, based on learning algorithms, are able to enact behaviors and actions in the world that respond to some of our deepest drives and values, but are performed according to a logic that is opaque to us, that is emerging from a different place, from a different set of motivations and understandings. I'll give you another example. This is a screenshot from a project called the Next Rembrandt project. This was an undertaking that was developed by a Dutch bank called ING. They wanted to understand what the cutting edge was of innovation a couple of years ago. So they said, well, Rembrandt is a major cultural asset to our culture. This is something that, one of the Dutch masters, this is something that we're very deeply proud of, and we think expresses something profound about the human condition. We want to understand what an algorithm would make of this. So they fed the entire corpus of 400 known Rembrandt paintings into a learning algorithm. That learning algorithm was used to do things like how many people are in this painting, and what is the distance between their eyes, and what direction are they looking in, and what color of the clothes are they wearing. And then this algorithm was used to projectively generate a new painting in Rembrandt style that never existed before. And this is what we're looking at on the screen now. I am myself not an art historian. I wasn't trained in art history. But I would have a hard time distinguishing this painting from a genuine Rembrandt. To me, it feels there's a certain soulful quality to this painting that feels very much as though it were generated by a human heart, a human eye, and a human hand. But no human being was ever involved in the production of this, least of all the historical painter Rembrandt. 450 years after he died, an artificially intelligent system produced this painting. The conclusive subject of a Rembrandt painting, it turns out, is a white man in his mid-30s looking over his right shoulder, wearing a dark outfit with a white collar, and so that is what the algorithm produced. It's not even merely that this is a screen image. A special 3D printer was developed to lay down the pigment in a way that modeled onto what Rembrandt supposedly did with his paintbrushes. There is an ineffable quality to this image, but it departs utterly from the human. And the uncanny thing about this to me isn't simply the one image that was produced by an algorithm. It is that you could then take that same algorithm and produce 1,000 paintings, 1,000,000 paintings, an arbitrary number of new paintings that Rembrandt never had anything to do with. Again, centuries after his death, this algorithm could crank out new acts of culture, new acts of knowledge, new implementations of something that we regard as profoundly and uniquely human, that again have departed completely from our understanding or our control. I'll give you a final example. This is the well-known algorithm Alphago, which is used to play the game of Go, the game of Baduk, as we call it in Korean. What we see on the screen is a human master named Lee Sedol. A couple of years ago, Alphago challenged the human master to a competition, and eventually Alphago prevailed. How did it do that? Well, at that time, it worked. It had two different mechanisms that were involved in understanding the game of Go and prevailing upon it. They had something called a policy network and a strategy network. Essentially, the algorithm was trained on every game of Go that had ever existed. It studied the strategies that grandmasters used. It eventually turned these into a positional algorithm that told it from any particular move in the game what the best historical strategy was to take. And using this sort of division of labor, it prevailed against Lee Sedol. And then the engineers hit on a new way of doing things. They said this division from a policy network and a strategy network, it's too complicated. From now on, we're not going to train the thing at all. We're just going to tell it what the rules of Go are, and we're going to set it loose. What it does, what the algorithm does, is it splits off different versions of itself, and then it plays games against itself. And it sees which game prevails, which pattern did better than the other pattern. So in the next championship match that this algorithm played against a human opponent, it did this. Overnight, between games, it played 1.2 million games against itself, against randomized opponents of equal capacity. So it split itself. It made itself opponents that were equally capable, and then it played against those opponents 1.2 million times overnight. Imagine the capacity that's involved in doing that. It learned how to play Go from scratch, from zero, from nothing. This is the holy grail of artificial intelligence. This is called unsupervised learning, and it happens fast. How fast? Well, at 0 days, like I've said, the algorithm has no prior knowledge of the game of Go, only very basic knowledge of the rules as input. It plays itself over and over and over again. It determines the winning strategy. By 3 days, it had already surpassed the ability of the version that defeated the previous world champion in 4 or 5 games in 2016. Then the learning curve gets steeper. It slows down a little bit. At 21 days, it had surpassed the ability of the version that defeated a higher ranking grand champion in 3 of 3 games. At 40 days, a little bit over a month, it surpasses all other versions of itself and becomes unquestionably the best Go player in the world. It has mastered a body of human knowledge that was evolved over thousands of years, and it did so in 40 days. 40 days, entirely from self-play, with no human intervention, using no historical data. Thousands of years of human knowledge over just a few days. Not merely that, it discovered new knowledge. It developed unconventional strategies and creative new moves. And this is the impression I want to leave you with. If you get nothing else out of this talk, the impression that I want you to take away with you is that it invented new knowledge. It developed entirely on its own strategies, not merely for playing, but for winning the game of Go, that were so profoundly counterintuitive and non-human that they made observers physically unwell to watch them. I mean, imagine that you understand the game of Go. You're familiar with it. You've been playing it perhaps since you were a child. Imagine that over that time, you've come to internalize the sense of what a good move is, what a good move is not. Imagine then that there is this post-human entity that plays the game with such incredible finesse and subtlety that its moves don't make any sense to you. It's winning. It's winning so fast and so capably that it outcompetes any conceivable human challenger, but it's doing so in a way that doesn't make any sense to you. You can't read its logic. You can't read its moves. You don't understand its motivations or its justification. It is outcompeting humanity in a way that absconds from our mind. We'll never understand it. Even to look at it is to become a little bit nauseous, a little bit queasy, a little bit unwell in here. It's so counterintuitive and disturbing to us. The algorithm achieves results that we specify according to a logic that is utterly, utterly opaque to us. And here's the other important part. That logic may not be retrievable, even in principle. Because the way that a convolutional neural network works is to sever the causal relationship between an input and an output. There is no way to determine how the algorithm, and again, these algorithms are everywhere in our lives now. They determine things like, will we be offered credit? Or what way will be rerouted on the highway? Or what opportunities and services will be offered to us in life? There is no way in the operation of one of these algorithms to determine which pattern or state of affairs in the world led to its recommended output, led to its outcome. So I want you to remember that the next time you hear this phrase, the next time you hear the phrase algorithmic accountability, understand that somebody either doesn't understand something or is actively being dishonest with you. Because the more advanced a machine learning algorithm gets, it crosses a threshold of understandability. We will never, even in principle, be able to determine what some of these algorithms are doing, why they're doing the things they do. They have evolved this pattern in such a way as to break the relationship between input and output in a way that's comprehensible to us. It's not so much that we don't understand the technologies we use. It's that we can't understand the technologies we use. And the result is a world tuned for other minds. What is the object on the screen that I'm showing to you? A couple of years ago, a London-based entrepreneur, a woman named Jo Liss, showed two objects side by side. The first object was a fairly standard mounting bracket, a little piece of hardware, very much like the ones that might hold this podium together or that object over there, the kinds of things you might find on a hardware store, $500 to a bucket for just a few dollars. The thing about these mounting brackets is that they're relatively self-explanatory. Even a child can look at them and say, okay, from the form of them, from the shape of them, we kind of understand what this thing is for. We might not have any mechanical aptitude our own selves. We might never have bolted together a table, but we understand that there is something that holds together the pieces of this table against the force of gravity and allows it to hold things up. It basically explains itself to us. It looks like what it does. You take a bracket like that and you expose it to an algorithmic process of topological optimization. And this on the screen is what happens to it. This is the bracket topologically optimized so that it is the most efficient. It has the highest strength to weight ratio achievable. This is the optimum arrangement of atoms to hold up a given weight amount of force in the world. This is what the algorithmic world looks like. Remember I was talking about strategies in the game of Go that make us feel a little bit unwell, that feel a little bit alien to us, so alien, in fact, that we find them disturbing. This is what more and more of the world is going to look like physically as algorithms begin to optimize the things around us. This is an object metaphor for what the world begins to look like when it is shaped by entities that are not driven by our sense of justice, not shaped by our sense of harmony, not shaped by our sense of proportion, but are shaped strictly by logics that they themselves understand. And here we find ourselves in terra incognita. Here we find ourselves truly in territory that we do not understand. Now, so far I've presented these notions to you, these ideas, as though they were inevitable, as though they were bound to happen. It is true, they're not inevitable. But at this very moment in time, they're currently overdetermined, which is to say that there are so many forces arrayed in our world, so many powerful actors in our lives that want this to happen, that it is the most likely outcome of all the scenarios before us. It is very, very likely, not merely in our lifetimes, but over the next few years, that we will see more and more of our world transformed along the lines that I've suggested to you today, meaning more and more of the world slips out of our ability to understand it or relate to it. It becomes, in short, an economy that is decoupled from human labor, a society decoupled from any human accounting of worth. We start to live in a time of post-human knowledge, knowledge devised, generated, and deployed not by ourselves, or by anything that looks like us or acts like us, but by systems that operate according to logics that we will never understand, that are beyond the capacity of our minds to map. Now, we need to remember that behind every appearance of this thing that we call the post-human, we must learn to see the all-too-human. At the origin, at the seed state of most of the algorithms that deployed in our lives, there is a human ambition. There is an ambition to sort, there is an ambition to categorize, and there is an ambition to assign people and things and spaces to these categories. And very, very often there is human bias and human prejudice embedded in these categories from the very beginning. So as machines increasingly begin to sort and order our lives, we need to remember that perhaps the less felicitous, the less happy parts of our souls are the ones that become embedded in them. We need to be very careful about that. Because if these biases and these prejudices become embedded in the algorithms, they'll be iterated on and on and on, over and over and over in everything we do. If we are careful, that might not happen. But right now, we see more and more of this happening because we haven't taken very great care about preventing bias and algorithm being folded into these, bias and prejudice being folded into these algorithms. And this is something to pay attention to. Nevertheless, it is a time for the transvaluation of all values. This is what the machinic production of knowledge implies to us. As algorithms increasingly generate more and more of the knowledge of our world, we lose control, we lose the ability to understand, and so we need to be extremely, extraordinarily, exquisitely careful about how it is that we allow these algorithms to govern our world. If we are, the limitless possibilities before us are magical. But if we do not, I ask you, remember with a little bit of caution what the world might look like as we pass its control over to things which draw their inferences and enact their decisions based on logics that we will never understand. In a time of the transvaluation of all values, the question really is, what indeed will we make of it? I thank you very much for your time and attention. Good morning.